is example 2.1, example 1. And what I want to get across to you is the idea of how to make a secant line, or sorry, how to make a tangent line using a secant line. So if we have a curve, and again, don't write this on your paper, this is just for you to look at. If you have a curve and you want to find a tangent line to a curve, do we all first of all know what a tangent line is? Do we know? No? All right, if you have any kind of curve, let me just pick a circle. Say you have a circle. You have a line that would be a secant line. This is a secant line. It crosses a circle in 2 points. A tangent line is one that touches the edge of the circle. That's a tangent. Okay. And one of the things we want to do in calculus a lot is find the equation of a tangent line. That specifically has a lot of purpose. Okay, we don't have to worry about what the purpose is now, but being able to find the equation of a tangent line, being able to find the slope of the tangent line are going to be key components to calculus as we go along. So that's something we're going to spend quite a bit of time doing. We're going to find several different ways to do it. Oops, I don't want to group, I'm going to cut. All right. So what they're going to do is say find the equation of the tangent line to some curve at some point. So let's say this is the point, let's call it point P for point of tangency. And I want you to find the equation of the tangent line through that point. All right? And what we have to do is find the slope of that tangent line. And you can't find slope at one point. But we will have the equation of the line in the problems we're going to see today. The ones we see on Monday, we're going to get a set of ordered pairs, basically. We won't get an equation, but we'll be able to approximate a slope on those. That won't be as accurate. And I can't remember the third day what we did. Anyway, there's several different ways we look at it in this lesson. What we do is, if this is the point of tangent, let's just say it has some coordinates. Let's say it's 3, 4. Let's say that's the point. Okay, we're going to know that point. We're going to create a second point on this curve somewhere, doesn't matter where. We're going to call that Q. And that point's going to be XY. All right. And if I were to connect P and Q right now, the way it looks, I would get a secant. All right? And what I'm going to do, though, is I'm going to take Q, and I'm going to move it closer to P. Maybe. There. You move Q closer to P, and then your line is getting closer to being a tangent. And then you move Q closer to P, and your line gets closer to being tangent. All right, each time you move Q closer to P, you're getting closer to the tangent line. So what we're going to do is we're going to find the equation of the slope of the secant line. We need to have 2 points, but we're just going to keep moving Q closer and closer and closer to P. If I land it right on top of P, there's no slope, because basically the same point, I can make any line go through that point once. But to keep making the secant line, as I get Q closer to P, as it becomes infinitesimally close, as close as you can get, basically you look with an electron microscope, you can't even see the space between it. That secant line, the tangent line, have almost exactly the same slope. We make a guess as to what the slope is, and then we use that as the slope of the tangent line. And then we go through the whole algebra process. We have a slope, we have a point, we find the equation of the tangent line. All right, so that's what we're going to do today. We're going to create a secant slope formula. We're going to use our table on our calculator to approximate the slope as we get closer and closer and closer to P. And then we're going to make a guess as to what the slope should be. All right, so here we go. Find an equation of the tangent line of the parabola y equals x squared at the point 1, 1. All right. No graphing is necessary to do this, but just to give you a visual, if I've got y equals x squared, 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4, right? It's just a parabola. The point I care about right here is point P. That's my point of tangency. That's the point that I want to have an equation of a tangent line to. And Q is some other point on the curve. All right, and again, it doesn't matter where Q is. I'm going to put Q right here to begin with. Q is just XY. All right? Now, what you have here, what this chart I have here, this is, in my opinion, the easiest way to get around what we're trying to find, is X paired with the slope of PQ. The slope of PQ is what we're looking for. All right, so what I want to do is I want to establish a slope formula for PQ. What are the coordinates of P? 1, 1. And the coordinates of P are X or Q or XY, right? Now, the problem with Q is there's too many letters. X and Y are different letters, right? Can somebody tell me what Y equals?
Y equals X squared.
Y equals X squared, right? How do you know that, Chris?
Because Y equals X squared.
It says right here, doesn't it? Y equals X squared. All right, so if we take a look at Q then, and instead of saying Q is equal to the point XY, we change it now. Q is actually the point X comma X squared. Now we're only using one letter to represent Q, and that letter is X. So when you see a problem and they give you an equation, this is the easiest type of problem there can be in this family of problems. All right? So if I wanted to slope from P to Q, applying the slope formula, what does the slope formula tell us to put on top? Going back to algebra 1, if we had 2 points, let's say my points are x sub 1, y sub 1, and x sub 2, y sub 2, what's the slope formula?
It's X sub 2 minus X sub 1.
On the bottom, and
Y sub 2 minus Y sub 1.
y2 minus y1 on top. That's the slope formula, right? So again, I only have 1 point for real, but this second point, Q, represents points on the curve. If I know what x equals, I square it, that's a point on the curve, right? So x comma x squared represents how these points come out. All right, so for example, if x is -1, -1, 1, that's a point on the curve. -2, 4, that's a point on the curve. +2, 4, that's a point on the curve. So this point here is representing any generic point on the curve. I can pick x, square it, and then I got a point on the curve, right? So the Q is going to be moving along this curve. If we change x, the point's moving along with that change in x. 0, 0 on the curve. 0.5, 0.25 on the curve. So that point is any point on the curve. I can move it. I have freedom of movement because x is a variable. My formula says y2 minus y1. Let's call it qy2. So y2 minus y1 is going to be x squared minus 1. x2 minus x1 is going to be x minus 1. So I'm just applying algebra, applying the slope formula of algebra with the point they gave me and the abstract point I created to have 2 points to be allowed to use the slope formula, because that's what's required for the slope formula to be used. That right there represents the hardest part of the problem, creating the slope formula. If this was an uglier equation, it would be all that stuff minus 1. Because whatever y equals, that's what goes in this spot here. So if y equaled 3x squared sine of x plus tangent of x, x comma 3x squared sine of x plus tangent of x, whatever I just said. Something along those lines. So the point, Q is going to be x comma whatever the function is, and the point of tangent is going to be whatever the point of tangency is, in this case 1, 1. The function minus y over x minus x. All right? Once we create the slope formula, now we're going to use our calculator. All right, I'm going to go here, I'm going to type in my slope formula in my calculator. So x squared minus 1 in parentheses divided by x minus 1 also in parentheses. Now notice my calculator says right there y1 equals. I have to know that the y column of my table is not going to be y, but it's actually going to be slope, right? Because that's what this is. This is slope of the secant line in terms of x. So when I put in x, the outcomes are all slopes. And my goal is to get Q closer and closer and closer to P. So what should x be getting close to?
0.
If I want Q to get close to P, what should this be?
0.
No, not 0. I want to get point Q, which is here, close to point P, which is here.
1.
1. We want to get X closer and closer to 1. So as X gets closer and closer to 1, P and Q are getting closer and closer to each other, right? Can we all see that okay?
Yeah.
All right. So if this is 0, 0, that's closer to P than it was there, right? And then if it's 0.5, 0.25, now it's closer to P than it was. If it's 0.9, 0.81, it's closer to P than it was. In each case, as X is getting closer and closer and closer to 1, my point Q is getting closer and closer to P. And if it's right next to P, so that I couldn't even slide a piece of paper between those 2 points, that secant line and the tangent line are almost exactly the same. The slopes are almost exactly the same. So I might be able to make an educated guess as to what the slope should be based on what I'm seeing. So if I go to my table and I start picking values close to P, and when I say close to P, I'm going to start off 0.5. That's not close. Might seem close, but 0.5 is not very close. Then I'm going to go to 0.9, 0.99, 0.999, 0.9999. Just keep on getting closer. Can't pick one though. So watch if I go to my table. I'm going to try this. So 0.5 first, then 0.9, 0.99, 0.999. 0.9999. Every one of those is giving me nice, friendly answers, right? Watch what happens when I type in 1.
Error.
Error.
Oh no.
Why do we think it's an error at 1?
Because that's what the point is.
So we're trying to find the slope from P to P, right? What's 1 minus 1?
0.
1 minus 1? 0 over 0 is indefinite. Okay? Indeterminate. We learned that in Algebra 1. You can't, 0 over 0 is an indeterminate form. 17 over 0 is undefined. That's 0.
Is that where you put the 0 and put a line through it?
No, it's indeterminate, meaning that it might have a value, but we can't determine what it is. Okay? There's an actual answer to this problem. There's an actual answer. In this case, specifically, back when we did Algebra 1, and I said sometimes 0 over 0 equals something, this is a situation where 0 over 0 equals something. All right? Sometimes it equals infinity, sometimes it equals negative infinity, sometimes it equals 2/3, 7, -5. Okay, it's indeterminate. You can't determine it until you get to calculus, and then we got ways to determine it. So, but keep in mind, my calculator can't determine it because it's not smart enough. You're smarter than your calculator. You have the capacity to think. All right. Look at the values we're getting on y1, which are slopes. As we get closer and closer and closer to P, 1.5, 1.9, 1.99, 1.999, 1.9999. What does it seem like they're getting close to? They're getting close to 2. You just evaluated right then, using your own brains, what 0 over 0 equals in this problem. 2. All right? So what I should get if I put 1 in would be 2, if my calculator is smart enough to think, but it can't think. It can only say error, because it's programmed to say 0 on the bottom is bad. All right, which is fine, that's true. So what I want to do here with this is I want to establish these values. So it was 0.5, 0.9, 0.99, 0.999. I think we wanted 4 nines, didn't we?
Yeah. Just leave the bottom one open.
Yeah, that's fine. I put too many boxes on there. Okay. So what we're doing here is we're getting really, really, really close to 1 from the left-hand side, and our results seem to be approaching a value of 2. Okay. That represents a guess. It's not necessarily correct. I'll go ahead and say for the sake of this problem it's correct. But you need to make a determination based on the numbers. But you have to come from the other side also, because there's some weird functions out there where coming from one side it equals one number, coming from the other side it equals another number. We need to make sure they equal the same number. All right? So coming from the other side, in other words, start Q too big, and then come back to P this way. So if I let X equal 1.5, that's close to P, but not very close. What would be a number closer to P that is less than 1.5?
0.4.
How about closer than that? See how I jumped from 0.5 to 0.9?
1.1.
1.1 is a good one. And then one closer than that would be 1 point, start adding zeros, 1.01, 1.001, 1.0001. Again, just getting as close as you possibly can from the right-hand side. We throw those numbers in.
You don't have to take the other numbers out of your graph.
No. It looks like it holds about 11, so as long as you can see them on the screen, they're fine.
Alright.
So, But look at the outcomes here. Again, x is the x coordinate, y represents the slope of the secant line. Notice at 1.5 it's 2.5, and 1.1, 2.1, and so on like that. So 2.5, 2.1, 2.01, 2.001, 2.0001. Again, just recording the information on your paper. I expect on your homework problem, there's 3 problems tonight, that you have an x paired with m table coming from both directions and establishing a good slope. So looking at this, what do you think m is?
2.
2.5, it's getting closer and closer and closer to 2 also. So notice the guess on both of them is 2. So we're going to say that 2 is the slope of our tangent line. All right, is everybody comfortable with that? Okay, back in Algebra 1 when it said find the equation of the line, job 1 was find slope, job 2 was find y-intercept. All right, and we had all these different ways to find slope. If we got 2 points, we used the slope formula. We said we're parallel to another line, we found the slope of that line. It was the same, perpendicular, we had the slope of that line, we had to make the opposite reciprocal. In calculus, to find slope, this is how you find slope. They're going to give you a point and a function. You apply a slope formula to a generic point with the point of tangency. You get really, really, really close to that x-coordinate on the point of tangency, and you guess what the slopes are getting close to. That's how you find slope. Once we know what the slope is, we're back in Algebra 1. We have a point 1, 1, that's the point of tangency. We have a slope of 2. And we know that lines fit the structure y equals mx plus b. So we simply substitute those 3 values, mx and y, in for these 3 guys to find out what b equals. 1 equals 2 times 1 plus b. Move the 2 over, change the sign, you end up with 1 minus 2 is negative 1. So the equation of the tangent line is y equals 2x minus 1. Would you like to take a guess as to how we verify if that's the right answer? Put it on a graph. So if we go over here, I'm going to clear this out because we found the slope, right? What was the original function? Y equals what? X squared. So let the original function be y1, enter, and then the second function is going to be the tangent line equation, 2x minus 1. Now I could do a zoom standard to begin with, but let's think about this, basic graphing here, right? X squared just squares what x is, right? So if we go to my window, let's say x goes from negative 3 to 3. What's the biggest that y is going to be?
9.
9. X squared, 9, right? And y equals 2x minus 1 goes below the x-axis a little bit, right? So let's make a y minimum, let's say of negative 5, and a y maximum, let's say of 9. No magic numbers here, I'm just trying to have most of the graph used up by these 2 functions. Hit graph. There's y equals x squared, and hopefully our red line is going to touch it at one spot, right around 1, 1, bam. It looks tangent, which tells me I'm right. Okay? If it didn't look tangent, let's say, I don't know, let's say for some reason we thought the slope was 3, and I would have got 3x minus 2 if we did all the algebra right. There's my y equals x squared. And now you can see it obviously isn't tangent. It hits here, but then it hits here again up there somewhere. All right? So you should be able to see tangency. And if you're wrong by a little bit, it looks pretty close, but there is one right answer, and that would be the one we just found, y equals 2x minus 1. Again, that's all you have to do to verify. Graph your function, graph your tangent line equation. They should look tangent in the picture. If they are, pat yourself in the back, you got the right answer.